So these are notes from Professor. Just want to go over them mostly for me so I don't forget them, because this is a refresher on node voltage and the Thevien equivalent. So when we look at this, we have the following circuit right here. And if we want to find the Thevien resistance, we are going to open circuit our voltage, which is what we have right here. And that's where we basically use the node voltage method, which we have right here. And we are going to find the Thevenin's equivalent, which is what we have right here, and what we have right here. We can see the Thevenin's equivalent is the same for both of these, and that's because this resistor is in parallel with this resistor, and voltages across resistors are the same. So to find this, we have the voltage we want to find set equal to our source voltage, and this is being multiplied by the resistance that this is happening over, and the resistance that this VT of H is happening over is our R2. And so then we have to add or sum the voltage that it's between and the voltage that are the one that we're looking at is over. So we know that R2 is the one that's associated with this VT of H, and our V source and our VT of H is going to do some math over our R1, and that's how we get the open circuit voltage. Now for dead circuit resistance, we are going to set our VT of H to 0 so that we can find our Thevien resistance. So once that's set equal to 0, we know that R1 and R2 are in parallel, so we set them in parallel right here, and we leave our R3 alone. And so we're just going to add our R3 with these two that are in parallel, because once we figure out the parallel of these two, it's in series with our R3. And remember, to do the dead circuit resistance, we're going to turn off independent sources but keep dependent sources. However, for this course, we are only looking at independent sources. And that's it for the notes for this specific material.